All right. So first thing I want to do today is to just lay out the test for you. And I'm going to lay it out two different ways. Just by the topics being covered and then kind of the breakdown of different questions. All right. So up on your screen right now, you have a breakdown of the different topics. All right. So there are 60 questions, 60 minutes. So each question you have about 1 minute to answer it. Okay. A lot of questions won't take that long. Some questions will take 2 or 3 or maybe even 4 minutes. All right. So what I would suggest going into a test, and I'm sure Mr. Genuine has told you this, have a watch, like have something that actually takes time. If it's a stopwatch, if it's a wristwatch, whatever, have it out on your desk and be able to check it. All right, because it's very helpful in managing time and managing where you're at. All right, if you're 40 minutes into the test and you've only done 20 questions, it might mean skipping ahead for those really, really tough questions. Okay, so skipping those questions altogether, maybe guessing or taking an estimated guess and going on to easier ones that you can get to later on in the test. All right. So of those 60 questions, there are a couple different topics. Okay, there's pre-algebra, which covers things like operations, types of different numbers, and just in general, like different terms of mathematics. Okay, stuff that you've been probably talking about for, again, since fourth, fifth, sixth, all the way up until right now. All right. Think of that as like middle school math. All right. Then there's elementary algebra, which, as you see on the screen, I've written as eighth grade in Algebra 1. So that is really like solving one-step equations and balancing different equations using fractions, stuff like that. Okay. Proportions is part of it. So being able to do all that stuff is really, really important. Okay. Then there's intermediate algebra. Think algebra 2 when you see this. So quadratics. There's some logarithm stuff in there, which we'll try and go over a little bit later. Graphing, interpreting different things in that algebra 2 context. Okay. Then there's coordinate geometry. So think lines, think distance and midpoint, graphing lines, areas, volumes, perimeter, stuff that Mr. Genuine just had you do. All right. So hold on to what you did for today. We're going to start kind of at the very, very beginning, and we'll get to that stuff in a little bit. All right. After coordinate geometry, there's planar geometry. So this is angles, triangles, circles. You covered a lot of this stuff your sophomore year. It has to do with angle totals of polygons, angles of intersecting lines, parallel lines, perpendicular lines, stuff like that. Okay. So being able to interpret that terminology, use it, and then use this the set of rules that you should have learned, which I'll remind you of, on different diagrams and things like that. Okay. Then there's trigonometry, which SOHCAHTOA, triangle ratios, and different trig functions. Okay. So that's the test. That's all the subjects. All right. It's literally everything you've covered in your high school career and even a little bit before. Okay. But even if it was covered before, it's things that you should be able to do fluently throughout high school. All right. Okay. Any questions about what I have written, the layout of the test, anything like that? All right. So as a little bit of a primer, I would like you to do this problem up top. It seems really simple, but it's something that I come across that a lot of people will get wrong. And this is kind of like a foundational thing that if you get this type of thing wrong, it sets you up for failure on a lot of different problems that rely on order of operations. Okay. So I'd like you to take like 30 seconds, jot it down on a piece of paper, whatever you're working with, and just try and do it. Once you get an answer, hold on to it, and we'll kind of talk about it just a little bit. Okay. So again, quick problem. What did you guys get? And you guys are all muted, so make sure if you do respond, unmute yourself. And again, we can actually talk about this. You got 9. How did you get 9? Okay, so tell me exactly what you did. What was your like process? Okay. And then what? Yeah. Great. Did anyone else get a different answer? Okay, good. That's perfect. Some people, and I wanted to address this really quickly. Um, some people will do. They'll distribute this too for whatever reason. So they get 6 divided by 6, which ends up being 1. All right. If you did that, that's okay, but make sure you know that the way that Harry did it is perfectly correct. All right. The order of operations, I know it seems simple, and I know people have been kind of telling you this all the way throughout. It's super important, especially when it comes to the ACT. Okay, so there's a lot of problems that rely on it. Getting that correct is like crucial. All right, it's foundational. Okay, so if you need to fix that, please do fix it. All right. Okay. So moving on from that, I kind of want to talk a little bit more about what I have written on the screen in a little bit different of a way. All right. So breakdown by question of the test. Okay. So we have all those subjects that we just went over, but it doesn't really tell you, how many questions of each. This does. All right. General breakdown, and this isn't necessarily always correct, but it's pretty close. And they may change it from year to year, plus or minus 2 on each section. But this is, I guess, the test that I was looking at, the book that I was looking at. All right. So it goes 33 algebra, where 14 are pre-algebra, 10 are elementary, and 9 are intermediate. Okay. And I have kind of descriptions of what each of those means. All right. So if you just consider 14 pre-algebra, so there are 14 questions that rely on you doing basic operations and talking about basic principles of math and being able to use a little bit of number theory. That's 1/4 of the test. Getting every one of those problems correct is, again, very, very crucial, which is why I'm trying to make a big deal out of order of operations. Even if you think you understand it, like one slip up, like distributing that 2 first, can mean getting one wrong answer. All right. And those are the 14 questions that we absolutely need to get correct. All right. That's I can't stress how important that is. All right. After those pre-algebra, there's 10 elementary. So that has to do with inequalities, linear equations. So think y equals mx plus b, ratios, percents, um, proportions. Again, those questions should be very, very easy. They're usually written to be interpreted a little bit differently, and a little bit harder to interpret, I should say. But in the end, it boils down to doing very, very simple operations, which are the things that we absolutely need to get correct. Okay, so if we can get all 33 of these questions correct, you're in a really good position. All right, which is part of my job right now. It's to make sure you can do those very, very quickly, very, very efficiently. Um, and we'll get to that calculator stuff here in a second. So if you do need to check those 33 algebra problems, you can. Okay. Then there's 23 geometry. So 14 planar geometry. So again, angles, lengths, triangles, perimeter, area, volume. And then 9 coordinate. So again, slope, distance, midpoint, parallel and perpendicular lines and their equations, and then graphing. Okay. So really, these first 14 is like what you would think of as actual geometry. It has to do with angles and lengths and stuff like that. These bottom 9 questions are equations of lines, using graphs to graph them, finding slope and stuff like that. All right. And then the last couple are trig problems. Okay. So SOHCAHTOA, graphs, identities, being able to use those trig ratios, sine, cosine, tangent. Those are those 4. All right. Now, there are hard ones within each of those. So in algebra and the intermediate ones, there might be some logarithms, there might be some exponents. There will be harder probability questions. So just keep that in mind. Like, even if you see a question like, oh, that's definitely an elementary algebra one, it may be a little bit trickier, but this is the ultimate breakdown of an actual test. Okay. So I want to pause for a second. Are there any questions about what you see up on the screen? Okay. So our goal today is to really cover these first 14. All right. And maybe a little bit into the next 10. But it's to really hammer down the pre-algebra stuff so we can build off of that. Okay. So if you consider us, we're taking the first fourth of the test. We're going to explore what that stuff means, how to approach it. And I've got some homework for you that covers all this stuff. All right. So there are some things that we need to go over first, and these are things that I consider we must know. All right. So order of operations. Can someone just tell me really quickly what they are? Okay, so what's the excuse part? Yeah. Then what? Yep. Great. All right. And again, I just want to make sure people actually understand what this actually means. Um, Anything in parentheses, the innermost parentheses should always be done first. All right. after that, any exponents. And then we have two that are kind of on the same level, multiplication and division. So those are kind of the same thing, and I'll explain what that means here in a little bit. And then we have addition and subtraction. Okay, which again kind of mean the same thing. They're on the same level. They're doing kind of a similar function on a graph. All right. So when we did that, 6 divided by 2 times 1 plus 2, the way I look at this is actually just in terms of multiplication and division. Okay, so I rewrite this divided by 2 as 6 times 1/2 times 1 plus 2. Some people, again, find that harder. That's the way I look at it. I kind of ignore division first, and then I ignore subtraction, and I take things just multiplication and just division, or just addition, sorry. Okay, and then when we do that, when you can simplify to just multiplication and addition, you multiply first and then add later, all right? So then we have different properties that you guys have learned before. All right, we have the commutative, associative, and distributive properties, and then the identity properties, which are pretty basic. But does anyone know these right off the top of their head? All right. So you probably do. You just don't know the names of them. So commutative. So say we have 3 plus 2. That's the same thing as 2 plus 3. We can switch the order of addition. All right. Same thing with multiplication. If we have 3, what's that? Yeah, it's fine. You just don't know the names. That's all right. Same thing with multiplication. So 3 times 2, that's the same thing as 2 times 3. All right. Associative, we're looking at how we can associate numbers. All right. So if you have a plus b plus c, we can rewrite that as a plus b in parentheses and then plus c outside. And we can group them in a whole bunch of different ways. Okay. So associative is kind of grouping numbers. Again, same thing with multiplication. If we have 2 times 3 times 5, right, we can multiply the 2 and the 3 first. All right. What about distributive? What does that mean? This is the one normally people know right off the top of their head. What does that mean? Tell me what you mean. Okay, so if we have a times b plus c, how can we rewrite that? Yeah. Yeah. All right, good. Okay. So again, this is the one people normally know, but often the one that people get wrong the most, which is fine. We'll go over plenty of examples. And then the last one is the identity. So what do you think the identity property actually says or means? If I say something is identical, what am I saying? Yeah, it's the same, right? So if we're talking about addition, what can I add to something to make it the same? So like what plus 5 is going to be 5? Yeah, it's 0. And then what would I have to multiply by to get the same thing? So what would I have to multiply by 5 to get 5? Yeah. Okay, and that's all that's saying. There are 0 properties too, which I guess we can add up here. Okay, so what would I have to add to 5 to get 0? What do I have to add to 5 to get 0? All right, it's just negative 5, right? So if I ever add the negative of our number, we get 0, right? So if we have 5 plus a negative 5, even though we're adding a negative number, so we're going to the left on our number line. Okay. What would I have to multiply by 5 in order to get 0? Any number times what is 0? Yeah. Okay. So those are the properties that we should know pretty well. Again, you guys might know the names of them. It might look funny when I'm using variables. But in principle, you guys should know when you see something multiplied by 0, it ends up just being 0, right? When you see something multiplied by something in parentheses, you should know that you can distribute to each of those things. And then you can add in any order, you can subtract in any order, multiply, whatever, so long as you're following the order of operations. All right. So any questions over those properties up front? Again, you don't need to know the names, but does anything look way out of the ordinary or something you have never seen before? Okay. And then some like basic terminology that we should know. Um, Things that show up a lot, even and odd numbers, which I'm guessing you guys know. Evens are like 2, 4, 6, 8. Odds are 1, 3, 5, 9, and so on. Um, Factors, right? So real quick example, what are factors of 12? 2 and 6. What else? Yep. 12 and 1. And then you could have all those things reversed, and then you could also have all those things, but all negative. All right. So some questions on the ACT are like, what are the even factors of some number, right? Or what is the sum of all the even factors of some number, right? Again, sounds really difficult, but as long as you understand those two definitions, you can get through the problem. Okay. Another term that shows up a lot is prime. Does anyone know what a prime number is? Except one in itself, right? So what is an example of a prime number? So kind of, but think go a little bit higher than that because 2 isn't. Yeah, so 5 is prime, right? What else? Sure. 23 is, 29 is, 47, things that you can't break down like we did this 12. Those are all prime numbers. Okay. So if you want a prime factorization of something, what do you think that means? Okay. So a prime factorization is splitting a number into multiples of primes. Right. So if we were to get the prime factorization of 12, okay, we can consider 2 a prime here. So we'd have 2 and 6, but 6 isn't prime. So we have to break that down into 2 primes. So what 2 primes multiplied together get 6? Yeah. Okay. So then this 2, 2, and 3, that's our prime factorization of 12. Okay. Does that make sense? Okay. I'm hoping it makes sense to the other 4 people in here. But that's what that means. And you can go in bigger numbers, and it gets a little bit more difficult when you go into bigger numbers. But we're just talking about breaking numbers into multiples of just primes. All right. Okay. Questions about anything you see up on your screen? Great. All right, moving on from that. One more kind of like terminology type thing, and then we'll get into some practice problems, and then we'll get into calculator stuff. Again, I'm not like super, like this stuff is very, very important. I'm hoping though that really we're covering this all 5 days. Okay. But it's in the context of other things. So we're just like kind of like laying the foundation right now. All right. Um, and the last thing we need to talk about are the different types of numbers, because that type of terminology comes up a lot in the ACT. Okay. So from Algebra 1, from Algebra 2, maybe even the beginning of geometry or in middle school, what different types of numbers do you know about? Okay, so there's odd numbers. What else? Okay, great. So these are different types of numbers, but they exist in a certain set of numbers. Actually, they exist in a lot of different sets of numbers. Um, and those are good, like, first parts. But what would you call all of the numbers you have ever worked with besides the, like, square root of -1? Basically, if the number exists, it's called what? Okay, let's start a little bit different. What numbers do you learn how to count with? Like, like, just start naming them. If you were to count objects, what numbers would you use? If I said count the circles, where would you start? Okay, so start counting them. Great, great. But we start with 1 and we just continually going up. All right. These numbers that you can count with, are called counting numbers. But in any math like place, like anyone talking about mathematics, they're going to refer to these as the natural numbers. All right, so we have this tiny little circle, this subset of numbers called the natural numbers. What would be like the next numbers that you learn about? All right, so if we have a number line, yes, we have 1, 2, 3, and 4. And that's moving right. What if we moved left? Yeah, so we'd get 0, negative, -1, -2, -3. Right. What would you call those numbers? Does anyone know? Yeah. Okay. And then what if we maybe landed in between somewhere? What type of number would that be? If we landed exactly halfway between 1 and 2, what number is that? It's a decimal, sure. What's another name for it? Do you know? So, like, what decimal would that be? If we're halfway between 1 and 2, what would that be? 1.5. We could also write that as 3 halves, which is a fraction, right? These would be called rational numbers because it is a ratio of 2 integers, basically. All right. And then there's irrational numbers, which kind of has its own little subset. That'd be like the square root of 2, right? It's like 1 point something, 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 and it continues on forever, and it has no end. Another number would be like pi, right? Or e, which you might have learned in a business class, or exponential growth. But these are called irrational, meaning it cannot be written as a ratio of 2 integers. Okay. So we have all these numbers, and then we have, like, all of these numbers are called real numbers. And those will be the numbers that we mostly deal with on the ACT. Okay. There is another set of numbers called the imaginary. Right. So this mainly, for your guys' sake, has to do with the letter I, which is equal to the square root of -1. All right. Which shows up sometimes. We'll get to that once we cover exponents and stuff like that. But this is the breakdown of all numbers, right? So there's natural numbers. Those are the numbers that you learn to count with, like 1, 2, 3, 4, and so on. There's rational numbers, there's integers, which are kind of on the opposite end of a number line. And then there are rational numbers, which are ratios of 2 integers. There are irrational numbers. All of those things are real. And then outside of all those things are imaginary numbers. Okay. Again, we're focused mainly on that center graph. And if you had me freshman year, which I know Apple and Liam did, at least for that first semester, this is like one of the first things we covered. Okay. So you've definitely seen this before. I know it. And it's not super important that you know every single number in every single set. But being able to identify a number as real, imaginary, or rational, or an integer, like that's important. And oftentimes the ACT will use that terminology, and it just helps peace of mind knowing what they're talking about. Okay, so sometimes they can say, what is the, you know, product of two irrational numbers, and then they'll just give it to you. Okay. There's not a whole lot of thought, and it doesn't really matter, but being able to uncloud like the unimportant parts is very crucial. All right. Does that make sense? Or am I just like totally out there right now? Okay. Basically, I'm trying to define a couple of terms so that you don't get confused by it when they show up, even if they aren't important. That's all we're doing right now. All right. Okay. Um, so this is really like sixth through eighth grade, sixth through seventh grade. Is just work with numbers, right? Those properties, order of operations, um, and this is a lot of that pre-algebra stuff. Okay. Now, I haven't said anything about word problems or anything like that, but what I would like you to do is to take, let's say, the next like 10 minutes, and if you guys could go to your class notebook. So if you go to Teams on the left side of your screen, go to class notebook on top. You might have to hit that little arrow. Um, and then in the content library, there's a page called the basics. Click that page. And then like a little like, sidebar will show up. Go to PEMDAS and fractions. Right, so you will get this. Okay. So what I would like you to do is take like 10 minutes and just do those things. All right. It's very basic stuff. Just a little bit of multiplication, division, and order of operations. All right. So I'll give you till like 3:05. And then after that, we'll talk a little bit about the calculator and how it can help you on some of this stuff. All right. And then we'll go through like a kind of a tutorial of it. And that'll be it for today. Okay. Is anyone having problems getting there? You're right. So you cannot get there? All right. Okay. So in that team section, right, ACT prep. Yeah, it's in the content library stuff. Yeah. Yes. Yep. Yep. I wouldn't even unjoin. I would just take 10 minutes and do this. This shouldn't take you very long, so you don't have to like hang up or anything. All right, so we should be about finishing up. Um, let's just go through all of them, and we'll go through any questions. And then after this, we'll get to the calculator stuff. And again, that'll be about what I want to cover day one. All right. So number one, anyone want to volunteer? Okay, and how did you get it? Okay, so when you do the 4 minus 2, you get 2, right? But that's inside that center parentheses. So it's really 3 times 2, not 3 plus 2. Okay. Yeah, so then that's 7 plus 6, which is still 13. Yeah. All right. Anyone else want to volunteer for number 2? So I do want to talk about number 2, so that's okay. Does anyone know what you call these types of fractions? Yeah, that's what I would call them. I think some people call them proper fractions for whatever reason. But yeah, these would be called mixed numbers or proper fractions. Okay, so this is 2 and 2/3 times 1 and 1/3. Okay, so I'll tell you how I would go through that. I would convert this 2 into thirds, right? So instead of 2 and 2/3, 2 really becomes 6/3, right? And actually, let's do this. 2 plus 2/3 plus 1, sorry, times 1 plus 1/3. Okay, so that's kind of how I would think about this. All right, and then we have to deal with fractions. So how do we add 2 and 2? 2 plus 2/3. How do you do that? How do you add fractions without the same denominator? Okay, so if we're adding these fractions, we got to get the same denominator on both of them. Okay, so I would have to multiply this left-hand term by 3 over 3. And the reason we can do that is because of that identity property that we went over a little bit earlier before. Okay, so because we're multiplying by 3 over 3, it's really just 1. So everything's staying the same. So when we do that, we get 6/3 plus 2/3, which is equal to 8/3. Okay, then we'd have to do the same thing with the 1 and 1/3. Okay, again, we have to multiply this left-hand number by 3 over 3, which again we can do because of that identity property. So we get 3 over 3 plus 1 over 3, which is 4/3. Okay, so then we have to multiply these two numbers together. And how do we multiply fractions? Can anyone tell me? Okay, so what do we get? 8 times 4, right? Yeah. So, no. So you cross multiply when there's an equal sign in between them. So if you had, like, there would have to be a variable in here somewhere. But if there was 8/3 x equals 4/3 or something, then you cross multiply. But because that equal sign is not in the middle, you multiply numerators together and denominators together. So 8 times 4, that's 32. And then 3 times 3 is 9. So then we have to look at our answers. All right. And what I would do, again, there's a lot easier way to do this, which we'll go over here in a second. But this is like the long way. Okay. How many times does 9 go into 32? How many whole times does it go into 32? Well, 9 plus 9 is 18, plus another 9, that's 27, and then plus another 9 is over 32. Okay, so 9 goes into 32 3 times and then with a little extra over. Okay, so it can't be E because we went over. It can't be A because it goes into 32 at least 3 times. It can't be C because of the same reason, and it can't be D. So our only option left is option B. Okay. Does that make sense, or is that like, did I just go over people's heads? Basically, we know that our answer will be 3 point something. Like there will be decimals there, so it can't be any of the other answers. Okay. Again, does that make sense, or is that okay? So that's one way to get answers. I know Mr. Genuine probably went over that the science portion, the English and the reading. Sometimes they're just close guesses, right? So you don't necessarily even have to go through all that stuff. Like you could do 2 times 1 and know that our answer has to be at least 2. So if there was an option like 1 and something, it couldn't be it. Okay, so a lot of this stuff is elimination. All right. All right. So then number 3. Did anyone get an answer for number 3? Yes. And how did you get that? That's okay. Okay. There are two kind of different ways I would look at this. You can either type it into a calculator, just do 11 slash 22, and then I'll get your answer. That's easy enough. If you want to, you don't even have to do that. All right. Uh, that's okay. Again, that's something we're going to go over here in a second. But another way you can look at it is 11 is just over half of 20, just over half of 20, right? Okay. So it's about 1/2, right? Which is 0.5, correct? Okay, so that gets rid of 1.8, 0.11, and 5.5. And really, it gets rid of A too. So your only option left is C. Okay, so if you just look at that fraction for a second, realize the numerator is about half the denominator, and take an estimated guess, and you get a pretty close answer. Okay. Um, does that make sense? All right, great. Number 4. Anyone want to volunteer? Sure. What do you get? Okay. And how did you get it? Great. Great. Perfect. That works. Um, yeah, that is exactly how I would go about it. Again, there are other ways to do it, which I will show you here in a second. But that's perfect. Okay. Anyone want to do number 5? I can do number 5. This requires a little bit of calculator work. 2 to the 5th. First, I guess I'll simplify this up front. So 6 squared is 36. 2 to the 5th, that is 32. Right, that's 2 times itself 5 times. Four squared is 16. And then 7 squared is 49. One thing I will say about, and this brings it up pretty well, there are certain powers that you just kind of need to know. Like, you should definitely know 6 squared. You should definitely know 7 squared. Really, you should know everything squared up until like 12 or 13. Okay? So like, if I say, give me 7 squared, you should automatically think 49. Right? If I say 12 squared, that's a little bit harder, but that was probably on all your multiplication sheets when you were younger. 12 times 12 is always going to be 144. Okay? You should know most of those. You don't have to know all of them. The common ones, though, like 6, 7, 8, 5, and below, like all of those you should definitely know. All right? So when we do this, 32 divided by 16, if we're following order of operations, that's 2. Then we have 38 plus 49, which is 87, right? Yeah. So our answer is E. And again, we can plug that into a calculator really, really easily and get an answer a lot quicker than what we just did. What about number 6? Tanner, what about number 6? Okay. Great. Perfect. What about number 7? C, how did you get it? Yeah, great. What about number 8? Someone give me number 8. So let's think about it for a second. How do we undo minus 13? What's the opposite of minus 13? Yeah, just regular 13, right? So we have to add 13 to both sides. And when we do that, we get x is equal to 30, and that's our answer. Okay, and this brings up another good point. And again, this isn't something I would suggest you do on the ACT, but it helps you think about it. If you have x minus 13, if you just write that, we have to get x by itself. So we have to do the opposite of everything else, right? So we have to add 13 to both sides. This is how I think of it a lot of the times, just to simplify it. It takes a little bit more time, but we always want to do the opposite of the operation in order to get it to the other side. All right. Does that make sense? At least a little. Great. Okay. Number 9. I'll do number 9 because I want to talk about that a little too. So we have 35.367. Okay. First thing I want to talk about here are just the number places, right? So what numbers place is the 3 here? What would you describe that as? Right, but like, what is that 3 place? What digits place is that? It's probably been a while since you've talked about this, so you might not even know like the question. Yeah, it's tens. What is the 5 place? Yeah. What is this 3 place? When you have, yeah, go on. Not quite. If you have 0.3, you have 3 what? Tenths, right? And then what is the 6? Mm-hmm. Yep. Great. Okay, and what this question is asking is to round to the nearest tenth. All right, so we are looking at our tenths position, but in order to round, we have to look to the 1 directly to the right of it. And since this is above 5, we round up, right? So then it's 35.4. Does that make sense? Great. Okay, number 10. I'll do this one real quick. We have to simplify inner parentheses first. And then work our way out, and we get 82. All right, so questions on those first 10. Okay, great. So what I want to do now is to look at our calculator a little bit and maybe give you a short tutorial on it. At least things that you didn't know. So if you don't have that out, go and get it out. And it's going to take me a minute to get it out. All right, so this probably looks a little bit like a mess. You have a bunch of audio and visual stuff down below. Don't worry about that. Just worry about the calculator part. All right, can everyone see that? It's like a TI-84 on the screen. Okay, great. So what I want to do is to quickly go over a couple of those. Well, first I want to kind of show you the calculator in general. And you guys have been working with this for a little bit, but I want to show you some things that you might not have known. All right. First, can you see my mouse? I'm guessing you can. I'm hoping you can. All right, great. So there, on all of those little buttons, there's a blue word above it, and then some of them there's a green word above it. All right, in order to access like the blue part, you always hit the second button. All right, so if I wanted to do like the term above it, we would hit second entry. All right, so the second button and then the enter button. And that gets like the previous thing that you typed in. Okay. But that gets us to a lot of different menus. All right. Let's see how I want to do this real quick. let's do graphs first. So on the y equals top left-hand corner, we can graph different equations. And one thing that I come across is a lot of people don't know that you can type out x like as a variable instead of just like doing alpha x. There's just a variable button, which is bottom right, like kind of catty corner to that second button. It's going to highlight red. Okay, we can actually type out equations like that, and that's going to come in handy when we're talking about intersecting lines, when equations meet, when they're equal to each other, and when we're talking about quadratics and logarithms and all the stuff like that. All right, so we're going to be using that y equals stuff a lot, and the x's and writing equations in here. Another button that I kind of want to make sure you guys know where it is, in order to square something, right? It's that red button right there. If you want to maybe cube something, like let's say 3 cubed, you would type out 3, then the upper caret, and then do whatever number you're taking that exponent to. Okay. And then if we were to graph that, you won't be able to see this. So if nothing shows up, we'd go to zoom, and then we'd go down to zoom fit. Okay. And then it'll give us our graph. All right. So a couple things. Y equals, where you put the graph, the exponent, the variable, the exponent, and then the graphing button. And then I want to quickly look at that zoom button just one more time. So if you go to zoom, there's a whole bunch of different options. There's zoom in, which should be self-explanatory, right? So if you hit this zoom in button, you'll have a cursor on your screen, and wherever you hit enter with that cursor, it'll zoom in. So if I go all the way down to the bottom, hit enter, it's going to zoom into that point. Okay. It's the very same thing with zoom out, but it's zooming out instead of zooming in. All right. The decimal, it just gets us a really small version of the screen. So instead of our units being like ones or twos, it's, let's see, it goes over by decimals, right? Go back to the zoom button. If we want to get our standard zoom picture, like our standard screen, so 0 to 10, 0 to -10 to the left and right, and then 10 up and 10 down, we would hit zoom standard. So zoom 6. And then again, you can't see our graph because it's higher up, but that's what's happening. Okay. As soon as it stops loading. All right. The other one that I think we should know is the zoom fit, which we just did. That basically looks at your entire graph, determines kind of the window for you, and lets you see a big picture of the entire thing. Okay. So that zoom menu, it's got a bunch of things that seem a little bit confusing, but they're really just doing exactly what they say they're doing. You're zooming in, you're zooming out, you're going to the standard screen, and then you're basically letting the calculator fit the screen for you. Those are the 4 ones that I would know right off the top of my head. Okay. And again, this will come in handy a little bit later. I just want you to see this right off the bat. Okay. So any questions about what I just said? I know I'm going by a little bit fast, but these are things that I don't think any teacher has necessarily told you yet. But you may have like discovered it on your own or whatever. But I just want you to know it so you can use it a little bit later. Okay. Now, on certain graphs, we will have to find the zeros and where they intersect. So I'm actually going to type in two different equations here. I'm going to type in x squared, and let's say 3x plus 2. All right, so now we have two different equations. And what this does is that it actually sets both of them equal to each other. All right, so that would be like on a, I'll write this out, hold on. On a problem, this would give us 3x plus 2 is equal to x squared, right? And we would have to solve for x. So instead of getting everything to one side, using the quadratic formula or factoring, we can use a couple of different features to help us. All right, so if we graph this by just hitting graph, and then we can go to our standard screen by hitting zoom 6, we get a graph that looks like this. We have two things that intersect each other, and we're basically trying to find where they intersect. Okay, in order to do that, we would do second, and then we would hit the calc button, which is trace, which again is highlighted in red, and it gets us this menu. All right, there's value, there's 0, minimum, maximum, intersect. What we're worried about is where they intersect, where those two things are equal to one another. So we'd go down to intersect, hit enter, and then it's going to ask us a couple of questions. The first thing it does is ask first curve. So basically it wants your cursor on one of the graphs that you chose. Okay, so in this case you just have to hit enter. And then it asks second curve. Again, so long as you're on your second graph, you can just hit enter. And then it says guess. And what we would do is we would go about to where you see them intersect. So in this case, I'm going to take that bottom left point, hit enter, and it's going to give us a point exactly where they intersect. Okay. Again, if you didn't necessarily follow all of that, that's okay. Just so you know it exists and about where to find it. That's what I want to happen right now, because we're going to be using this a whole lot when we're talking about quadratics, maybe even a little bit with inequalities, and things like that. All right. So is there anything that maybe went over your head or you didn't catch, or anything you want me to go over again? Okay, so I'll just kind of go over this real quick again. All right, so we want to see where those two things intersect, where the red hits the blue. All right, and there are really two intersections here. I'm just talking about the first one. All right, so we hit second and then trace, which is now that red highlighted button. And it brings you to this menu. Again, we want to see where they're equal, which is where they intersect, which is that fifth option. Hit enter on that, and it will ask you three different questions. The first one, so first of all, are you with me so far? Okay. The first question is first curve. And basically all that's saying is to put your cursor on the curve that you consider the first one. Put your cursor on the first graph. Okay. So it's on the blue graph. Great. We hit enter. Now we want it on the second curve, or the red graph. So we hit enter again. And then it says to guess. So we want our cursor to be somewhere near what we're talking about, which is about right here. Okay. If we wanted this intersection way up here, we'd have to go way up there. But we want this one way down here. So we click right near it. It doesn't have to be exact, but it has to be near it. We hit enter, and it gives us that X, Y coordinate. That's where those two things intersect. Make sense? Or did you at least follow it? Okay, great. There are a couple more things in that menu that I just want to call your attention to. So if we go back to second and then trace, um, there's a 0 option. So if you recall back to, I guess this just past year, you probably talked a lot about quadratics. And with quadratics, you had to find zeros by either using the quadratic formula or by factoring. Does that sound familiar? Okay. So basically, you have something like x squared plus 3x plus 2 or minus 2 is equal to 0, and you have to find where that graph intersects the x-axis. Okay? That 0 option will help you do that. So again, instead of factoring, and instead of using the quadratic formula, you just use this feature and it does it for you in a lot less time. And then there's minimum and maximum, right? So the minimum will get you kind of let's go back to our graph. The minimum would get you the bottom of that blue graph. And if that graph was upside down, like instead of kind of starting up and ending up top, it would start down bottom and end down bottom, then we would have to choose maximum instead. And that's really all that does. Okay. Again, we're going to go over this kind of at a later date. I just want to make sure people know how to navigate their computer, their calculator. Okay. So that's the calc menu, right? So we've gone over the zoom menu and we've gone over the calc menu, and I guess graphing a little bit as well. And those are 3 very important things because those can help you answer questions very, very quick if you know how to use the calculator. All right. And again, we'll go over questions a little bit later that allow you to practice that. But right now, I just want to make sure that we understand where those things are. All right. Cool. So let's go to second quit and go back to our home screen. Okay. Another thing. So I think one of our questions was like 1 2/3 plus, what was it? 2 2/3 plus 1 1/3. All right. So instead of going through all of that mess that we did, we can actually just type in 2 plus 2/3 times 1 plus 1/3. Again, so instead of finding the common denominator, adding fractions, and then simplifying, we can just type that into our calculator. Okay, so I would do open parentheses, which, there you go, open parentheses, 2 plus 2 divided by 3, and then close parentheses, and then open another set, and then 1 plus 1/3. If we type it in exactly like that and hit enter, we would get 3.55 whatever, okay? Which, if we look back at our answers, it would have to be 3 plus something else, all right? Which would still get us our answer. Okay, did that make sense? Are we following me? Okay, good. All right. The other one that a lot of people don't know exists. So I think one question was, what is like the decimal of 11 divided by 20? Yeah, 11 divided by 20. So if we just do 11 divided by 20, hit enter, we get 0.55, which is exactly the answer. And if we really wanted to check that, what we could do is we could do second Actually, not even second. If we just hit this math button, which is below that green button, and then we hit frac, so then it says answer arrow fraction, and then hit enter again, it gives us that fraction. Okay, so that's just a way to check it. So again, it took something that maybe takes 20 seconds and makes it like a 10-second problem, which is very important, especially when we're talking about these first like 30-ish questions. Maybe not 30, maybe first like 10 questions. The more time we save on those, the better. Okay, so even if it's like 5 to 10 seconds, those 5 to 10 seconds add up, and you can use them on harder questions that you can definitely get right, but that just take a little bit more time. Okay, so that math and then frac button is very important. That'll help you out just a little bit. And not even just on the ACT, but like next year in math class, that'll help you out. Okay, so questions about that? All right. There's one other thing that I thought I wanted to go over. But I think that's about it. All right. I do want to go over a couple more things in the calculator, and then we'll call it. Okay. All right. Yeah, I'll lay the foundation for this. One thing that we should know how to do, and again, this will help you a little bit later in the year, but also in the ACT when we're solving for systems of equations, are matrices. All right, so in order to get a matrix, we need to hit the second button and then the matrix button, which is that button highlighted red. And then within that menu, we have 3 different menus. We have names, we have math, and we have edit. Okay, so if you don't know necessarily what a matrix is, we'll go through that in a little bit. But we do need to know where this menu is to make it a little bit easier on us later on. Okay. Second and then matrix. So I'll go back to the main menu. So if we hit the second button and then the matrix button, that'll actually do a lot of matrix math for you. Matrices do show up sometimes on the ACT. It doesn't show up a whole lot, but they do appear. And this can help you a little bit. We'll cross that bridge a little bit later. I just want you to know where that menu is. All right. And then one other feature that I want you to know about is the stow feature, which can help a ton, especially when you're checking. All right, so one question was 2b minus 8 is equal to 12. All right, so hold on. Where'd it go? There it is. So 2b minus 8 is equal to 12. If we just type that out on our calculator, except let's use x, 2b minus 8, we can actually make that equation in our calculator. And we do that by typing out 2x minus 8. And then we go to math. Nope. We go to second math. And then we have this menu, which has the equal sign, the not equal sign, greater than or equal to, less than equal to. Okay, obviously we want the equal sign. And we want to type in 2x or 2b minus 8 is equal to 12. All right, so we're just typing out the equation right now. So once we do that, we can hit enter. Okay. And the answer that this gives tells us yes, that is correct, or no, it is not. Okay. So theoretically, we could actually store every answer on our options into our calculator. Okay. So right now, whatever x is, we just hit x, enter. We stored 0 as x. Okay. But we got an answer. We think it's 10. So we would type in 10. And then we would store that into x. Okay. So again, that store button is like bottom left, right above the on button. So we would do 10 stow x, hit enter, and now we know that x, the value in x, is just going to be 10 from now on. So then if we type out that 2x minus 8 and just hit enter, we get 12, which is exactly where we want it to be. We could also do 2x minus 8 and then do second test is equal to 12. And then we get a 1, which means a yes. So 0 means no, 1 means yes. Okay, and this is like I would use this on questions that maybe are a little bit trickier or you were confused about, like the second time you come around after you finished everything else. Okay, so this is when you have time, maybe a couple minutes left in the test, and you're like, that problem number 42 or whatever, I think I got it, but I want to check it. Okay, so this is that thing that you would do in order to help check it. Okay, so again, that store button is second, and then stow. Not second stow, it's just stow. All right, and then to get the equal sign, you do second math, and that brings you to that menu. Again, 1 means yes, 0 means no, or 1 means correct, and 0 means incorrect. You can also use that stuff without the variable. So if you have like a complicated like exponent problem, kind of like the 6 squared divided by, plus 2/5 divided by 4 to the second. Plus 7 to the second. So let's say we got our answer. And let's say that we got, instead of 87, which we know is correct right now, say we got 187, and we just want to check that. We would do second test equals 187, hit enter, and that 0 means we're incorrect. All right, so we did something wrong, and we have to recheck it. And really, you shouldn't even do that equal sign, right? Because if you just get rid of all this, and just hit enter, it'll get you the right answer. Okay, so I think I confused people a little bit right there. I wouldn't even do the second test on that. If it's just numbers and no variables, you don't even need the equal sign. You just hit enter. And I realize now I'm not even showing it. Okay, that's what it would look like. All right, so any questions about any of that? Okay, that like covers a lot of the calculator, at least a lot of the calculator that you probably haven't seen before. And we're going to be using this a lot in the next couple of days because it makes a lot of calculations a lot easier and a lot quicker, which is the important part. Okay. Um, so, what I would like you to do is to one, kind of keep this calculator in mind for now. But two, I would like you to start that homework. And when you can, use your calculator to help you with those calculations. All right. There are a couple of things that we didn't necessarily go over in the homework, but I wanted to cover the basics first. And then as you have questions, we'll kind of go over it next class. All right. So there are averages on there, which take a little bit of not like creativity or anything, not even cleverness. You just got to know like the definition of average, which we didn't go over. But I want to see what you guys can do kind of on your own right off the bat. All right. So are there any questions over anything on the calculator or anything that we went over today? Okay. So again, your homework is is in your notebook. So if you go to class notebook and in the basics section, there's a homework. And I think there's 31 problems. I would like you to try and do that. And again, when you go through it, I would like you to keep this calculator in mind because again, it can make your life a whole lot easier in a lot of different ways. Okay. And these are all like arithmetic word problems. So it doesn't require a whole lot of algebra, but it does require you knowing some of the properties, how to deal with mixed numbers, you know, visualizing a couple of things. So that those 31 questions, that's your homework. And what I would like you to do is come in with questions so we can address those right off the bat and maybe walk through them together. All right. So before we end, are there any questions over anything that I've said so far? Okay. That's all I have. All right. So again, your homework are those 30-ish questions. Uh, and we'll go over the answers or any ones that you found confusing next class on Wednesday. All right. No problem. And I'll see you on Wednesday at 2 again. Same place, same time.